Good morning, class. Today, I'm going to show you how to apply a couple of properties from section 4.4. Okay? Section 4.4 says, the name of section 4.4 is real zeros of polynomial functions. Okay? I will do for you guys problem number 73 on section 4.4. Problem number 73, number 73. This says 4.4 right up here. I don't know if you can see it. Okay. Number 73. Problem 73 says this. Look. Problem 73. It says this. Problem 73 says f of x equals to three x cubed minus 16x squared plus 17x minus 4. Okay. Now, I'm going to show you a property that it helps you find the real zeros. But first, I'm going to show you first a property that's called the rational zero test on page 306. Rational zero test. Page 306. Okay? Now what this means is this property is going to help us find the x-intercepts. Okay? Now in a few minutes you'll see why we rather call the x-intercepts zeros. Okay? Right? So it's best to call them zeros. So when I say the word zero, what I mean is the x-intercepts. Okay? X-intercepts. But it's best to call them zeros. All right? All right. So, this property allows us to find the possible zeros. Okay? It must be in descending order. First, the last coefficient, this coefficient, the constant coefficient, we're going to call it P. And the leading coefficient, we're going to call it Q. Okay. We're going to find the factors of P. What are the factors of P? Okay? So, the possible factors of P, or what goes into P, what goes into negative 4? The factors. Okay? Factors of P. Or what values go into negative 4. That's what we mean. What goes into negative 4? Plus minus 1. 1 goes into negative 4. Negative 1 goes into negative 4. What else? Plus minus 2. 2 goes into 4. Negative 2 goes into 4. Okay? These are the factors. Plus, minus 4. These are the possible factors of negative 4. Okay? What are the possible factors of Q? What goes into Q? What goes into 3? Plus, minus 1 and plus, minus 3. All right? Okay. Now, the possible zeros for this function is the following, or are the following. The possible zeros, possible, okay? Here are the possible zeros. I think it has 2 S's, I don't know. I'll leave it, 2 S. Yeah. Maybe not, I don't know, guys. Okay? All right, there we go. I don't care. Possible zeros are P divided by Q, which are, let's start with this one, plus minus 1 divided by plus minus 1. Plus minus 1 divided by plus minus 3. Plus minus 2 divided by plus minus 1. Plus minus 2 divided by plus minus 3. Plus minus 4 divided by plus minus 1. Plus minus 4 divided by plus minus 3. Okay. So these are the possible zeros, okay? From this one, you could say 1 divided by 1 is 1, or negative 1. Because 1 divided by negative 1 is negative 1. So here we get plus minus 1. From this one we get plus minus 1/3. From this one we get plus minus 2. From this one we get plus minus 2/3. From this one we get plus minus 4. And from that one we get plus minus 4/3. These are the possible real zeros, okay? These are the possible, for you to understand, real x-intercepts. There they are. All right. Now, how do we check? How do we check which one of these is a real zero or a real x-intercept? Okay, let's do synthetic division. When we do synthetic division and we get a remainder of 0 from the last lecture, then that number is a 0, okay? So we're gonna divide, let's try 1, okay? Let's try 1. So synthetic division. Take the coefficients, 3, negative 16, 17, and negative 4. Okay. Now let me start with 1. Start with 1. I'm trying positive 1 first. Okay. Now don't forget, if we get a 0 here, then the remainder is 0. And that means that this number is called an X-intercept. But it's best to call it a real 0. Okay? So we're trying 1 first. First step is to bring down. And then multiply. 1 times 3 is 3. Add. Negative 16 plus 3. And then multiply. 1 times negative 13. And then add 17 minus 13. And then multiply. 1 times 4 is 4. Add 0. Remainder is 0. That means that x equals 1 is a or an X-intercept or a real 0. Okay? Once again, because the remainder is 1, that means that x equals to 1 is a 0. And what that means, an X-intercept. Now, we said last time that whenever we get a 0, that 0 comes from a factor. Let me show you how to find that factor. So bring this over to the left. Bring this over to the left. So therefore, x minus 1 equals 0. And you see this x minus 1? That is a factor of this function. Yes. This is a factor of f of x. Nice. So therefore, f of x now, I need the room. I need the room, guys, okay? Okay, you guys have all the possible zeros here. I need the room. Watch this. F of x now is gonna equal to this factor, x minus 1, times this trinomial, and this trinomial is 3x squared minus 13x plus 4. Yep. If you multiply this times that, you better get the original problem. Hey, so we were able to find a factor using synthetic division, and we were able to at least name the possible zeros using the rational zero test. Okay? And there it is, look. You can do it again. You can see if one is a 0 again. Sure, why not? Watch this. Okay, so this is a 0, all right? So let's do it again. Let's see if 1 is a 0. So we do this, look. If 1 is a 0 again. If it is a 0, we're going to get 0 there now. The remainder. So what's the first step? Bring down. Multiply. Add. Multiply. Add. So the answer, this is not a 0. And because it's not a 0, x minus 1 is not a factor again. Okay? All right, so 1 is no longer a 0 of 3x squared minus 13x plus 4. Okay, no problem. That didn't work. Let's try another value on the list. Okay, let's try another value on the list. How about -1? Want to try -1? Try -1. See, because we have 1 and -1. -1. Okay, 1 and -1. Let's see if -1 is a 0. Bring down. Multiply. Add. Multiply. Add. No! -1 is not a 0 of 3x squared minus 13x plus 4. No, it isn't. So therefore, we're done with -1 and 1. Okay, let me try 2 first. See what happens, okay? I'm gonna try 2, okay? Later on, I'll try the fractions. But let me try 2 now. Try 2. Okay? I wanna see if 2 is a 0, which means I wanna see if 2 is an x-intercept. Bring down. Multiply. Add. When you add, what do you get? Is that -7? Multiply, -14. Add, -10. No. Okay. It isn't. 2 is not a 0. So we're done with 2. 2 is not a 0 because we didn't get 0 as a remainder. Okay? Let's try -2 now. -2. Okay? I'm going down the list, but I want to try the whole numbers first. Okay? Or the positive. Let me try -2 now. Okay? Bring down a 3. Multiply. Multiply. Add. Multiply. Add 42. So -2 is not a 0. -2 is not a 0. Okay? Okay? All right. So 2 times 9 is 18. Takes 1. 2 times 1 is 2 plus 1 is 3. Fine. Okay, so that didn't work. So we tried 2 and -2, and that didn't work. So far we just found that x equals 1 is a 0. Okay, so 2 didn't work. Let us try 4. 4. Bring down. Multiply. Multiply. Add. Add. multiply, add. Yes. 4 is a 0. 4 is a 0. Or you can say x equals 4 is a 0. And that means, what does that mean? Well, bring it over, subtract 4 from both sides, so x minus 4 equals 0. So that means that x minus 4 is a factor. If x equals 4 is if x equals 4 is a 0, then x minus 4 is a factor. Hey. So x minus 1, and now x minus 4, yes. Times what? You tell me. Times what? Right here. Times 3x minus 1. That equals to f of x. Yes. Yes. We found, look at this. We went down the list, okay? We used rational zero test. We went down the list, P divided by Q, the possible factors of P, possible factors of Q. Okay, we went down the list and we found we were able to factor this. If you can factor, then you can graph, okay? Because now we know that at x equals 1, we have an x-intercept. At x equals 4, we have an x-intercept. At x equals what? 1/3. We have an x-intercept. If you want to graph, watch this. Watch this. If you want to graph, by the way, once we found the first one, once we found x minus 1 is a 0, you can try to factor this. Yeah, you can try to factor this because now this may be factorable. It is factorable, look. Okay, it is factorable. But you don't have to go through all of this once you find x minus 1 to be a factor of f of x. Okay? But I wanted to show you guys how to find the 0 going down the list. Okay? I want to show you guys how to find the zeros going down the list that I gave you. Okay, very good. Very good. So now that you have it factored, look at this. Watch this. Okay. The degree for f of x is odd. The leading coefficient is positive. What's the conclusion? This function rises to the right and it falls to the left. F of x rises right, falls left. We have a 0 at x equals 4. Look, at x equals 4. If you set this equal to 0, at x equals 4, we have a 0. We have a 0 at x equals 1. Yes, we do. Okay. So watch this. 1, 2, 3, 4. And note, it rises right, and this is the largest 0. Okay, at 4. It's a 0. It rises right. Yeah. At x equals 1, another 0. At x equals 1, another 0 right there. These are the only zeros. So that means that this function has to come down and somehow turn around and go back up and pass through this. And it's going to cross because the multiplicity is odd. Okay, the multiplicity of x minus 1 is 1, which is odd. It crosses there. Multiplicity of x minus 4 is 1, which is odd. It crosses there. If it's even, it touches. Okay. It's got to behave like this. It has to. And so now, what's the other one? 1/3. So that's 1. This is 1/3, 2/3, and 1. Okay, so this function has to go up, and somehow it's going to have to come down and pass through 1/3. And if you want to find the y-intercept, let x be 0. For the y-intercept, let x equal 0. If x equals 0, plug it in. F of 0, that's 0, that's 0, that's 0. Oh, -4. So this is going to cross at -4. Okay, so -1, -2, -3, -4, and there you go right there. And so it's going to come down, go down, go down, go down, go down, and pass at -4 and go down that way infinitely. Okay, all right. So this completes section 4.4. By the way, there's another rule, okay? They call it the Descartes rule. Descartes rule of signs, okay? You look at the variations. So watch this. Descartes rule. Okay. First, you look at f of x. And we're going to look at the signs. So we have 3x squared minus 16x, 3x cubed, I'm sorry. 3x cubed minus 16x squared plus 17x minus 4. And just look at the signs, okay? That's a positive 3. That's a negative 16. That's a positive 17. And that's a negative 4. And watch this. Let's look at the change in the signs. Whenever we have a change in signs from a coefficient to the next coefficient, we call that a variation. Okay? So this is positive 3. From this positive 3, the first coefficient, and this is negative 16. So from positive to negative, it changed signs. So that's one variation. From negative 16 to positive 17, that's another change in signs. So that's 2 variations. From positive 17 to minus 4, that's 3 variations. So that means that this has, how many variations we said? 3 variations. This has, f of x has 3 possible zeros or 3 minus 1. What's 3 minus 1? I'm sorry, 3 minus 2, I'm sorry. 3 minus 2. So this f of x has 3 possible zeros or 3 minus 2. What's 3 minus 2? 1. It has 3 possible zeros or 1. I'm talking about positive zeros, okay? This is the Cauchy rule on page 307. Okay? It says the number of positive real zeros either equals the number of variations in signs occurring in the coefficient of p of x, or less than that number of variation by a positive even integer. Okay, so these are positive, possible, real zeros. How about the negatives? How about the negative real zeros? You try this. F of negative x. You plug it in. So what's negative x cubed? What's negative x times negative x times negative x? That's negative x cubed. So negative x cubed times 3, that's a negative 3x cubed. Okay? Plug in negative x there. What's negative x squared? What's negative x times negative x? That's x squared. A negative is negative is positive. So this is negative x quantity squared is x squared. So this is minus, remains the same, 16x squared. Plug in negative x there. So it's minus 17x minus 4. Okay. Okay. So let's look at the variations. From negative to negative, no. From negative to negative, no. From negative to negative, no. So here, this one has 0, negative. This has no negative zeros. And look, we were right, look. 3 or 1? We found 3. 1, 2, and 3. Okay? This is the Cauchy rule. Okay? All right. This covers section 4.4. Let's go to section 4.5. In section 4.5, we are going to try to find, let me see, more zeros. Okay? We're going to try to find more zeros. Guys. Yes. Before we go there, I have to show you something. I need you to understand this. Because now that we have all of this, look at it. Now that we have this, here's my point. Let me erase this problem. So this is section 4.4. This completes section 4.4. By the way, let me give you some homework on section 4.4, okay? I gave you homework already, but I want you to try some of these problems, okay? All right, good class. So I would like you to try Well, I'll give it to you at the end. How's that? At the end, I'll give you homework in section, more homework in section 4.4, because I didn't give you enough. Okay? All right. 4.5. We're going to try to find more zeros. Okay? The first thing to do is this. So we have the following. So we have f of x equals to 3x squared plus 12x plus, I'm going to say 1. Okay? All right. So what's p divided by q? You could try that if you want to. If you want to factor, you can. You can try to factor this. Okay? But it's not going to work. This is not factorable. I can tell you right away. It's not factorable. Okay? So you can try p divided by q. P divided by q, just what we did earlier. All right? This equals to plus minus 1. Okay? And then factors of this are plus minus 1. And then plus minus 1 divided by plus minus 3. Okay? So these are the possible zeros, guys, the possible zeros. So p divided by q, plus minus 1, it could be a 1, could be a negative 1. 1/3, negative 1/3. These are the possible zeros. These are the possible zeros. We don't know if we don't try them, okay? Let's try. So let's take 3, 12, and 1, and let's do synthetic division. Let's try 1 first. 1. Bring down a 3. Multiply a 3. Add a 15. Multiply a 15. Add a 16. No. This is not a 0. Okay. Let's try negative 1. Let's try negative 1. Bring down. Multiply. Add. Multiply. Add. No. Negative 1 is not a 0. Want to try a 1/3? Okay, try 1/3. Try 1/3. Okay, bring down. Multiply. What's 1/3 times 3? 1. Add 13. Multiply 13/3. Add. What's 13/3 plus 3/3? Is that 16/3? Is this a 0? No. Hey, what's going on, guys? What's going on is that this has no real zeros. That's what's going on. This has no real zeros. Why? That's my question. Why? Want to try negative 1/3? Okay, let's try negative 1/3. Try negative 1/3. Negative 1/3. Bring down 3. multiply. What's negative 1/3 times 3? Negative 1. Add 11. Multiply. What's negative 1/3 times 11? Negative 11/3. What's negative 11/3 plus 3/3? Is that negative 8/3? Is this a 0? No, because the remainder is not 0. Okay, so this is not working. And I never said this would work, okay? This gives you a possible list. It does not guarantee, oh, by the way, a possible list of real zeros. But it doesn't guarantee that any of them are zeros. It just gives you a list, okay? Didn't work. Why? What's going on here? Why weren't we able to find zeros? Why? It's the question. I'm going to show you why. Here's the reason why. There's two ways to find out. One way is to express this. One way is to complete the square. I'm going to show you. I'm going to graph it for you, okay? I'm going to try to graph this for you guys. Complete the square. So f of x equals 2. Look at this. Here's what I'm going to do. I'm going to divide everything by 3. Divide this by 3, divide this by 3, divide this by 3. And divide this by 3. Divide this by 3. Divide this by 3. Divide this by 3. Okay. I divided everything by 3. I'm trying to complete the square. Okay. Now, I'm going to take half of 4. I'm going to square that. I'm going to add it. And I'm going to subtract it on the same side. How's that? Okay. So, f of x over 3 equals 2. X squared plus 4x. To complete the square, remember, I'm going to take half of the coefficient of the linear, square that. So half of 4 squared. Okay? What's half of 4? 2. What's 2 squared? 4. So this equals 4. So I'm going to take this 4 and I'm going to add it and I'm going to subtract it, making sure that we still have the same function. I'm going to add 4. I'm going to subtract 4, just to make sure that we still have the same function, and then plus 1/3. Okay? I'm trying to show you why we were not able to find real zeros. We did P divided by Q, and we didn't find anything. Okay? All right. So now you guys have this. Let me erase it. Erase. Okay. I think I have completed the square. Why is that? Watch this. F of x over 3. You see this trinomial right there? That's x plus 2 quantity square. You see negative 4 plus 1/3? Isn't that negative 3 2/3? This is negative 3 2/3. All right. Okay. Now, so this f of x over 3 equals 2 x plus 2 quantity squared. 3 times 3 is 9 plus 2 minus 11 thirds. We almost have it. Let's multiply everything by 3. Multiply this by 3. If you multiply this by 3 here, the 3's cancel. We get f of x. Multiply this by 3. And multiply this by 3 also. The 3's cancel. There we have it. Can we graph that? Yes. That's a parabola. Okay. That's a parabola. Okay. Let's try to graph this parabola. This parabola opens up. Oh no. It's going to go down. Okay. Okay. All right. So let me go back and say just one more thing. P divided by Q allows you to find the rational zeros. Okay? It does not allow you to find the irrational zeros. P divided by Q is called the rational zero test. Because remember, from page 306, it's called the rational zero test, which means P divided by Q only allows you to find the rational zeros, not the irrational. The reason why we could not find the irrationals is because the zeros here may be irrationals. They are irrationals. Okay? So let's graph. Graphing. Okay. Go to -2, the vertex -2, -11. -1, -2, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. So -2, -11 right there. That's the vertex. It opens up. It opens up. Okay? How do you find the Y-intercept? Let x be 0. For the Y-intercept, let x be 0. Okay? If x is 0, that's 0, that's 0, 1. When x is 0, y is 1. Okay? By symmetry, because from here to there is 2, from here to there is 2, this must be also 1 by symmetry. Okay? So therefore, this opens up. Passes through this and goes up that way. It opens up. Passes through this and goes up that way. The reason why we were not able to find rational zeros is because the zeros are irrationals. The zeros are irrationals. How to find the zeros is the question. To find the zeros, let's set this equal to 0. Watch this. For the zeros, okay? Set this equal to 0. Okay? Remember, to find the x-intercept, you let f of x be 0. That's basically what we're doing. These are the x-intercepts. That means let f of x equal 0. So now this is 0. And we have 3 times x plus 2 quantity squared minus 11. Okay. Bring the 11 over, divided by 3. So 11 over 3 equals to x plus 2 quantity squared. Okay. All right. Take the square root of both sides. So now x plus 2 equals to plus minus the square root of 11 over 3. Okay. Bring the 2 over. And so we get x equals to negative 2 plus minus, and this is going to be, can I just multiply, everybody? Can I just multiply this top by 3 and this bottom by 3? Okay, I'm going to do that, class. So multiply the top by 3 and I get 33. Multiply the bottom by 3 and I get 9. Okay, so that x equals to negative 2 plus minus the square root of 33. And what is the square root of 9? 3. So that x equals to what? Negative 2 plus minus, and let me see, well, let me get them together, okay? Let me get these two together. If I'm gonna add those two, I better multiply this by 3 and by 3 in the denominator. The top by 3, which is negative 6. And the bottom by 3, now we can say all over 3. Okay? Guys, because of this square root, we have irrationals. That's why, this is why the rational zero test didn't give us any zeros. Because, look, they are irrationals right there and there. And by the way, they're both negatives. Okay? I know that the square root of 36 is 6. Okay, so this is less than 6. Yep, they're both negatives. You can see it right there. Okay? All right. So in section 4.5, now you're looking for all types of zeros. Yes, all kinds of them. Irrationals, rationals, and even complex. The nice thing about complex is the fact that you always get them in pairs. Whenever you get a complex zero, you're going to get the complex value and its conjugate. Okay? So see if we can give you an example right here. Okay? Here's an example. Okay? Let me try this example. Okay, so don't forget, every time you get a complex zero, it means that they'll come in pairs. Complex zeros come in pairs. The complex number and its conjugate. Okay? Here's an example. we have this. F of x equals 2 x cubed plus 2x squared plus 4x plus 8. Okay? You can do P divided by Q and go over the list. Okay? I'll let you guys do that now. I'm just going to go straight to the problem. I want to see if I can find zeros right away. Sometimes you can find them by just factoring. Okay? I'm going to do that. So watch this. I'm trying to find the zeros, okay? Because if I can find zeros, I can graph. Okay? So let's find zeros. Let's find zeros. Can someone tell me what zeros are? They are x-intercepts. As long as they are real. If they're complex, they are not x-intercepts. Okay, that's why x-intercept is not, it doesn't include all the complex, okay? The complex zeros. All right, so there we go. We're trying to find the zeros. We used to call them x-intercept, but this is a better name because this includes rationals, irrationals, and complex zeros. Okay, I'm just going to factor this. See if I can find some. I'm going to group those two. How can I group those two? Well, let's take out an x squared. X squared times x plus 2. Look, x squared times x is x cubed. X squared times 2 is 2x squared. I'm going to group those two. Plus factor out of 4. 4 times x plus 2. And that's f of x. Okay? You could have done this P divided by Q. You would have found 1, I can tell you right away. Okay? Now, so factor what? X plus 2 times x squared plus 4. And that's f of x. I'll tell you right away, if you had done with this with P divided by Q, watch this. If he has said, I want to do this P divided by Q, sure, that's P and that's Q. What are the factors of P? Plus minus 1, plus minus 2, plus minus 4, plus minus, right, 8. What's Q? Plus minus 1. You can, okay, now you divide, and so what do we get? Plus minus 1, plus minus 2, plus minus 4, plus minus 8. You can go down the list. This is not a 0. You can try it, but it's not a 0. I can tell you right away because we just found one of them there. Negative 2. Negative 2 is a 0. Not minus 1, not minus 4, and not minus 8. Negative 2. It's right there. Negative 2 is a 0. Okay? So you could have done that. You could have done it that way. Okay? All right. I'm not going to, because I already did it for you guys. Now, if you set this equal to 0, x plus 2 times x squared plus 4 equals 0. Watch this. X plus 2 equals 0. x squared plus 4 equals 0. X equals -2. X squared equals -4. X equals plus minus the square root of -4. Yes? Take the square root of both sides. And so x equals 2 plus minus what? 2i. All right. X equals 2i. This is a 0. If you bring it over, x minus 2i is a factor. The other one, x equals -2i. -2i is 0. Bring it over. X plus 2i is a factor. So we were able to factor this now. Look, f of x equals 2 equals to what? X plus 2, x minus 2i, x plus 2i. And there we factor this one, okay? What's the behavior of this function? Goes up. Up to the right, down to the left. Okay, so most likely, and what's the Y-intercept? 8. So this function does this. Okay, it crosses at -2. -1, -2, right there. It also crosses at 8. 1, 2, 3, 4, 5, 6, 7, 8 right there. Okay, so most likely it's gonna do this. Okay, it's gonna do that, and maybe, I don't know, maybe then it's gonna maybe go like this and then go back down. But I can tell you right away, it's not gonna go back up. That's gonna be the behavior. Okay, we're limited. We need more math to find out how it behaves right there, okay? We need a little bit more math. But right now I'm happy if you can find the zeros, okay guys? If you can find the zeros, I'll be very happy with you guys. This is section 4.5, okay? This coming week, I'm gonna start also getting to the other section, 4.6, 4.7, okay? We're almost done with chapter 4, all right? Thank you very much, good class. Oh, let me give you more homework on section 4.4, because I didn't give you enough. Okay, so do the homework that I already gave you. I gave you homework on section 4.4. I already gave you some homework, but let me give you some more. If you can just try a few more problems from section 4.4. This for your own benefit, okay? Obviously I can't collect it now. Okay? But try, for example, try 4.4. Try 50 through 80. Multiples of 5s. Okay? All right, so this is additional homework from section 4.4. Okay? All right, guys, I'm gonna see if we'll meet again. Okay, I'm gonna give another more lectures. I'll continue to do this as we continue. Okay, take care of yourself. Stay away from big crowds. Okay, stay at home if possible. Don't go out. Stay at home, be safe. All right, thank you much. I'll see you soon.